Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to a new lecture. Again, this lecture is spread over multiple sessions. In the first session, actually our lecture is on ANCOVA. So in the first session, we will start discussing the one-way ANCOVA. What is the difference between ANOVA and ANCOVA? Now, in order to illustrate the difference between ANOVA and ANCOVA, I will open an SPSS file. And this file I have picked up from the folder, which is intuitively part of the IBM SPSS when you install in your computer. And this file is actually, the data file is credit card, related to credit card. You must be familiar with this data file. We have already used this data in multiple earlier videos. Now in this part of a discussion, we are discussing ANCOVA. Now, what is the difference between ANOVA and ANCOVA? Well, using the general linear model, univariate, and in this univariate, if I select one dependent variable, for example, spending, and this spending, suppose if we consider any categorical variable or the variable which has certain categories, for example, it can be gender, it can be more than two categories, for example, the card type, example, type of item, और या card की हम type ले सकते हैं, तो जब हम इसको यहाँ shift करते हैं, और फिर उसके बाद ये post hoc analysis and options and all these things, for example, for ANOVA, ANCOVA, or any other type of analysis of variance, covariance. The first and the utmost important thing is checking the homogeneity. So applying the homogeneity test, we need to the selection of homogeneity test is must. The other mandatory part of the analysis is descriptive stats and the estimates of effect, and then the observed power. This much is part of the ANOVA. We are yet not discussing ANCOVA. So if we are estimating ANOVA, so this is sufficient. We continue. Before we continue, we can also shift here the card, and then here we do not need to select compare main effects, etc. if we are discussing ANOVA. But if you are discussing ANCOVA and you have more than two categories of the independent variable, then perhaps there is need. And so in case of ANCOVA, you need to select it if the independent variable has more than two categories. So we continue. And so far we have been discussing ANOVA. So isi tarah, if you want to run the post hoc analysis, now depending upon the significance of the Levene statistic, we can select the options. For example, ye jo hai Takei test, and if there is heterogeneity or there is heteroscedasticity of the variances, if the variances are not equal, when I say variances, it means the variance of the dependent variable across different categories of the independent variable. So if these variances are not equal, then we need to select this part, the lower part. Games, Howell test, Tamens, T2 test, वगैरह ये Takei test. So these tests are part of the ANOVA, simple ANOVA जो हमने पहले डिस्कस किया है. तो अगर ऐसा होता तो फिर हम ये टेस्ट लगाते, and we press continue, and if at the same time you are applying contrast, तो contrast के लिए हम यहाँ पे जाते हैं. But this time we are not, since this is simple revision of the concept of ANOVA, so we are not going into further detail. But contrast, if you want to know more about the planned contrast and contrast, you can watch other video lectures wherein I have discussed contrast in detail. Contrast again can be done in two ways that has been done in the previous videos. You can watch them. So yeah, this much. इसी तरह if you want to save certain things, but we are not saving this time. So if I click OK, so this much analysis is known as ANOVA. Now the homogeneity is mandatory to test. For example, in this case, since we are starting here, the univariate analysis of variance, this is variance analysis. This is unadjusted mean. For example, mean expenditure against this credit card, this credit card, this credit card. And so these are 1, 2, 3, 4, 5 types of credit cards against which the expenditures have been analyzed. So average expenditures on each card is mentioned here. Now, Levene is mandatory for ANOVA and ANCOVA for both. So Levene, according to the null hypothesis, as per assumption of the ANOVA, the variances should be equal. So null hypothesis states that the variance or the variance of the expenditures against all the 5 cards are equal. But when it is rejected, we say the variances are not equal. So the variation of expenditures across different credit cards are not the same. So then you need to apply the robust. So if you want to know detail of the robust test, then you can watch the relevant videos which have been placed over there. And then the other thing is about the significance. What is significance? For example, what is significant and what is not significant? And what is the effect size? So actually, partial eta squared measure the effect size. And the guidelines for measurement of effect size are acquired from Cohen's conventions. So according to the Cohen's conventions, 1%, 6%, and 14% are the criteria for small, medium, and large effects respectively. In our case, if you look at the card, it is 3.3%. So 3.3% size of effect actually falls between the small and the medium. So the size of effect is from small to medium. So small to medium. So this is how we can. Similarly, then the grand mean of the entire data spending on all overall spending on all the cards, their average, and then the comparison of, this is adjustment value of the average expenditures, and then post hoc analysis and all these things we compare. Since our results are significant, so therefore our main focus should be on Games Oval test and Tam-Haynes test instead of the Takei test. Takei test is relevant when we assume equal variances, and the variances are not equal, and this has been known from the value of the Levene test. So this is all about the ANOVA. Now coming to ANCOVA. What is ANCOVA? So if we, let me now minimize this output. Okay, and now univariate, now ANCOVA. ANCOVA actually comes from the covariates. So in the covariant, we pick up another independent variable which qualifies, which is considered as covariate, and it qualifies. It can be, in fact, the continuous variable, which means it has continuous values. For example, 2, 3, 2.5, 5, 6, 100, 100.2, and so on. So this is known as continuous variable. So we can shift it here. Now by having shifted this to the covariate box, makes it ANCOVA instead of ANOVA. So we will start this from next session. So this much is the comparison of ANOVA and ANCOVA. So in the next session, we will be focusing only on ANCOVA.